Now members, we are going to focus on how we get the median of a discrete random value. But please don't forget to subscribe to the channel. Now here, the median aim of a probability distribution function of a random variable x is the smallest value for which the value of x is greater or equal to 0.5. So when you have a probability which is equaling to or greater than 0.5, then this value of x becomes the median, this small x. For a geometric distribution function, f of x and median m, then the f of x of m should be greater or equal to 0. So now the immediate value that is given is 0.5 or just above 0.5, its value of x is the median, as you are going to see. These are going to be very crucial. We have x greater or equal to 2, the same as 1 minus probability of x less or equal to 2, greater than 2, the same as 1 minus probability of x equal to 2. Why do we need these ones? We need these signs here. Why? Because we see that these ones are the geometric mass functions. That's how we get them. Now from here, how do we start? The question is here. The PDF below is for a random variable x. This is our x, and these are the corresponding probabilities. Find the geometric mass function. So to get the geometric mass function, we keep on adding these probabilities. So the origin, the first here, 0.05. Now you get this plus this, you get 0.45. And when you get this plus this, you get 0.75. When you get this plus this, you get 0.9. And this plus this, you get a 1. So that's how you get it. In simple terms, this one means this is the f of 1, this is the f of 2, this is the f of 3, and this is f of 4, and then this is f of 5. So now the geometric mass function for 1 is this, for 2 is this, for 3 is this, for 4 is this, then for 5 is this. Then Roman numeral 2, so this was Roman numeral 1, so we have finished that. Then Roman numeral 2, find the median. Now the median, we say it's the f of m greater or equal to 0.5. Now to get the median, come in your geometric mass function column. You trace the value of x which is greater or equal to 0.5. In this one z, now we are using the cumulative mass function or the geometric distribution function. So it's like this one is not yet 0.5. So we are tracing for 0.5, something equal to it or greater. The immediate value that is going to give us this. This one is 0.45. It's not yet this. But this one is 0.75. So it's that it's greater than this. So the corresponding value of x that is giving us this, you see it's going to be 3. So here my f of 3 is greater, I mean it's equal to, it's greater than 0.5. Why? Because it's 0.75. This value is greater than that. Or if I'm trying it properly, I'll say my f of 3. Why am I saying f of 3? Because that the corresponding value is this, is 0.75, which is greater than 0.5. Now it can't be equal, because this one is just greater. So the corresponding value, now this one is going to be our median. So therefore, our median, the value of x is x equaling to 3. That's how we get our median. Now, if we found out that this was 0.5, now the median will be this. We base on the cumulative, not probability. We base on this if you have cumulative. So that's it. When you come to number 3, I have probability of x less than 3. Now we say that, now to get this, you want to get this, now we use the cumulative distribution function. So this one is the same as values which are below 3. Below 3. So this is the same as values starting now from 2 and below. From 2 and below. And we said that now, remember this one, f of this is the same as probability of x less or equal to 1. This is the same as x less or equal to 2. And this is the same as x less or equal to 3. Probability of x less or equal to 4. And this one probability of x less or equal to 5. So now you see, to get this, you just get this value here, which will be less or equal to 2. This is it's the same as f of 2, which will be the same as f of 2. And the corresponding value is 0.45. Or you can add this and this if you're using now probabilities. Or would be x equaling to 2 plus probability of x equaling to 1. When you add these two probabilities, which will be 0.4 plus 0.05, so you get 0.45. It's up to you. But here, the one who uses this method is written array. When you come to this now, remind numero 4, probability of x greater or equal to 3. Say, if you have this the same as 1, minus probability of x less now than this, which is 3. But we have seen this the same as 1, minus probability, this one is the same as x less or equal to 2, which will be 1 minus the whole of this is 0.45, which will be 0.55 with this. Or you add this probability equal to 3, or you add these probabilities here. You add these ones here. It's up to you. So then, yeah, start. This one is the same as f of 2 still, which you got there. The number 5, I want probability when x is less or equal to 3. This one is the probability when capital F of this is 3. And you start this one, capital F of 3 is just 0.75. Now this is how you can just get this probability. This is when you have this geometric mass function. Then when they come and they ask you, Roman numeral 6, they ask you f of 2. F of 2 is very clear. F of 2 is 0.45, which is the same as probability of x less or equal to 2. Why am I putting the less side? Because this is stimulative. But now they want to get f, number 7, f of 4.5. Now this one, 4.5, f of 4.5, see that we have not reached. So it's this one. You just say it's the same as f less or equal to 0. I mean, this is the same as, okay, interpret it properly. This is the same as 4. Or, you know how we interpret this? If we have f of 4.5, the same as probability when x is less or equal to 4.5. So, but we don't have the corresponding of 4.5, that's why we just go this. And this will see it's going to be 0.9 as the value. So those are the value members of these questions. So we are going to see now how do we sketch these functions in our next lesson. I wish you well.